Hello everyone, welcome to my YouTube channel Chemistry Lovers. Um, in this video, I have shown you to draw the pi orbital diagram, especially for unsaturated organic compound. So here I have written certain rules which you have to follow or remember while you are gonna draw the pi orbital diagram for an organic molecule, right? So first you have to remember these four rules, otherwise you will face a lot of difficulty in order to draw these diagrams. So I am gonna clarify you easily in this video. Please watch the full video, otherwise you can't understand the theory or the thing that I have tried to understand you. Okay, the first rule is numbering all the atoms present within the molecule, because we have to number all the atoms except hydrogen present within the organic molecule that has given to you in order to draw the pi orbital diagram. The first you need to remember that you need to numbering all the atoms present within the organic molecule. Second rule is state the hybridization of all of them in a chart form along with their bond angle. So you have to write the hybridization of all the atoms present within the molecule in a chart form. I have shown you later. I am now just showing the basic some rules you need to remember in order to draw the pi orbital diagram. Otherwise, you will face a lot of difficulty. So first, I will tell you the rules. Then I will go some examples through which you will understand more easily. Third rule is if any methyl group or any tetrahedral group present at the terminal position of the molecule, then that group should be neglected at first while you are going to draw the pi orbital diagram of that molecule. Because in order to draw the pi orbital diagram, you need to clarify your examiner that the unhybrid 2p orbital present on the carbon, because that's the main thing which is shown mainly through this diagram. That's the pi orbital or the unhybrid 2p orbital used in the pi bond formation, right? So if any group becomes tetrahedral in geometry, then that group you can draw this group at the terminal position in order to clarify your diagram more easily. And last rule is if there are any triple bond present within the molecule, then try to draw these groups or atom at the lower side of your page in order to understand clearly for unhybrid 2p orbitals. So these are the some basic four rules which you need to remember while you are gonna draw the pi orbital diagram. Now here I have written the first example, simplest molecule 1,3 butadiene. So for this molecule you need to draw the pi orbital diagram. So at first, according to the first rule, here I have shown you the pi orbital diagram. First, this page you can see I have numbering all the atoms present within the molecule. There are 4 carbon atoms present within the molecule and 2 pi bonds present between first, second and third and fourth. You can see easily. And now the pi orbital diagram I have drawn here. Since there are 1 pi bond present between first and second carbon atom, so there are, you should know that pi bond is formed between the partial or parallel overlapping between two unhybrid 2p orbitals. So these are those unhybrid 2p orbitals, and they are undergo conjugation with each other and form the pi bond. Similarly, case observed between third and fourth, and this is the sigma bond. Sigma bond is formed due to the axial overlapping of two orbitals, and pi bond is formed between the parallel overlapping. These things you should know, that how a bond is formed, and which kind of overlapping present in there, right? Otherwise you will get a lot of difficulties. Now this sigma skeleton here I have also written you. This sigma skeleton is need to draw in this case because through this way you can show that how or through which style you want to draw your diagram. Alright. So this sigma skeleton nothing but this sigma skeleton represent that only the sigma bond. You can see first and second carbon atom. There is a sigma bond. Second and third carbon atom also sigma bond. Third and fourth also. That I have only shown the sigma bond here. I have not shown here any pi bond because pi bond is already shown here, right? So I have only shown the sigma bond. Through this way, the teacher also understand clearly that through which style you want to draw the diagram or you have drawn the diagram of the molecule, and in this is the main chart through which you can sum up all those atoms and their hybridization, bond angle, geometry, right? These all things you need to write in this pattern. First you have to draw the pi orbital diagram of the given molecule, then sigma skeleton, and then this chart. In this way you can easily I think draw this. Another example I have shown you in this molecule. Here are also I have numbering 6 atoms present here, 4 carbon and 5 carbon and 1 nitrogen. Here I have written the chart form. Out of 6, first, second are planar trigonals, third and fourth and fifth and sixth are linear. So their hybridization I have also written here, and these are the pi orbital diagram. You can see that first and second consist a pi bond between them, while third and fourth consist 2 pi bond because they are sp hybridized. You know the triple bonded carbon are sp hybridized, possess 2 unhybrid 2p orbital on them. These are the 2 unhybrid 2p orbital. For better understanding, I have sketched this as a black line, and I am using black color in order to draw those unhybrid orbitals. You can draw these in blue color also. There is no issue with that, but you should differentiate clearly, or you should represent the diagram clearly, because these unhybrid orbitals are very important in this case, because these unhybrid orbitals are used for the pi bond formation, right? So these unhybrid orbitals, you have to mention these unhybrid orbitals properly, otherwise the teacher won't be understand your diagram and you won't be able a good marks. And this is the sigma skeleton. Just I have drawn the sigma bond. The pi bond are drawn here and sigma bond I have drawn here in this case. Now let us go for the next example. Here are also 4 carbon atom present, while 2 and 3 are sp hybridized, because sp hybridized means there are 4 unhybrid 2p orbitals present on the 2 carbon atoms. Here I have shown 4 unhybrid 2p, and this is the sigma skeleton, and this is your chart. So in this way I think you have an idea about the pi orbital diagram, and if you have any doubt regarding this topic or feel any difficulty, then please ask me through the comment section. I will definitely try to solve your queries, okay? And if you like my video, then please watch, share, subscribe my channel and hit the bell icon. Thank you.